Folks, we have a great session on AI. AI is changing the world, and when we talk about AI, it is actually the use of intelligence, and the intelligence is not artificial. Here we have a great panel of speakers. I want to start by asking each of them the areas in which they're working and what they're excited, explain about themselves. They've been introduced, and then we'll go straight to the questions, and we'll have them answer questions and give their views, and then we go talk to you and get your questions. Yes?
Solomon mentioned, my name is Stratos. I started my career as a data scientist when AI was perceived to be science fiction. And then I spent over a decade getting the damn thing to work. So I lived under a rock. I was honored to work for some of the most iconic companies in the world. So I was in the machine learning group at Apple. From the years of Steve Jobs to the Tim Cook era. Something that's very near and dear to your heart. I spent a lot of time in India working with the Ambani family to bring to the world the largest telecommunications company in the world, Reliance Jio. And we built one of the largest and most impressive AI organizations in India with 100% local folks from IIT. Recently, I worked for IBM. I was heading the AI group and engineering for IBM Watson as the VP of AI. And very recently, 2 weeks ago, I decided to go to a company that has a purpose in solving the problem with drug discovery. And AI plays a huge role in that. So with that said, I'll pass the mic.
Thank you. Actually, you should drop the mic on that introduction. Hi, I'm Charlie Isaacs, and have any of you heard of Salesforce? Okay, good. I won't go into the 25-minute presentation and description of Salesforce and what we do. Actually, we're in that building right there. You probably see that one. But I like to boast that I've got, by the way, thank you for any of you who are existing Salesforce customers or who are Salesforce users. Thank you very much. That's what I like to do first. But I boast that I've got the best job at Salesforce. My title is CTO for Customer Connection. It's basically CTO for IoT and emerging technologies, and I get to go out and do workshops with customers every day. I was in Chicago yesterday with a parking company, and they were connecting up their parking meters, believe it or not, to Salesforce. And everybody thinks of Salesforce as being a Salesforce automation tool, but we're a platform where we can manage multiple different functionalities and capabilities, and including, we're not known for this, but customer service. So they wanted to, you go up to a parking terminal or a parking meter and you have a problem or an issue, you should be able to push a button, or you should be able to speak to it, right? And say, hey, I've got a problem here, and it should help you, right? Someone should call you and they should know your context. So I focus on workshops like that, and occasionally it's with AI, especially since IoT generates so much data, and that's where I get hands-on with AI a lot, is our customers want to be able to leverage that massive amount of data and turn it into actions and business results. So that's what I do at Salesforce.
Thank you. My name is Ganesh, Iyer. Looks like we need to have at least one Ganesh in each of the panels. So to differentiate the other businessman Ganesh, I got a Ganesh V. Iyer. So that's me. A little bit about my background. I grew up in India. I started my career in '89 with Tata family. I was with TCS and privileged to work for Tata Chemicals, and I want to speak to you a little later. So mostly I spent my career in the IT technology industries until I met this gentleman, Elon Musk, back in 2011. And because I was at VMware, Tesla was just opposite. And Elon was not Elon today. Back then, he was just one of us, general human being. So still he is a human being. He's not a robot. Yeah, he was not a robot back then. So he said, I'm trying to do something truly breakthrough, which is to put the internal combustion engine out of business and electrify the entire world. So that was the bold ambition and the vision. So that's pretty cool, but I didn't know who Elon was. I read the Wikipedia, said, oh, yeah, he has done something at PayPal so cleverly well. Let me get into the Elon that bandwagon, which I did. I'm glad I did. Otherwise, I wouldn't be speaking here today. So I spent about 5 years at Tesla. Mostly, how many of you drive Tesla here? All right.
Wow.
Okay, quite a few. So I left, and then I met this gentleman, Dr. William Li. So he's a Chinese entrepreneur. He's known as Elon Musk of China. So his bold ambition, aspiration really excited me what he was trying to do. It is still electric cars, as you all know. China is the #1 auto capital in the world. And in fact, all the luxury cars sold in the rest of the world put together, China sells much more than that. So that is how big that market is. And I said, oh, that's a big market. I haven't done anything in China. Obviously, I'm an Indian. So I said, yeah, let me go and then get some experience with China. So I joined NIO 3.5 years ago. So we have 2 cars, 2 electric cars already being sold in China. What differentiates the NIO vehicle from Tesla's? So since we didn't have any legacy, I said to my team, we are not building a car. Think of we are building a supercomputer or a robot that happened to look like a car. If that is the case, how should that supercomputer be architected from ground up? Because I believe that the vehicle will become your next digital companion. It could become your third living space. Those of us who are workaholic, office is our primary home, home is our secondary home, car is our third home. Why can't we have productive, peaceful, and playful experience in the car? There's no reason why we can't. Technology has advanced. AI is the underpinning for that. I'm a strong believer in it. So that is a little bit about my background and then what I am here to represent, the NIO views of how we see AI evolving and some of the bleeding edge with respect to United States, China, and I can bring some India perspective as well.
Sure. So Musk
Thank
to
you.
Musk. You never left Musk.
I never left Musk.
Okay.
That's true.
Thomas?
Still my mentor.
Thomas?
So I can't thank you for being a Salesforce customer, and I can't ask you if you drive a Tesla since I don't either. But does anyone here have an affiliation with Berkeley?
Oh.
Great, so let me thank you for that. So I teach here at UC Berkeley. So I actually teach in this building, and my office is just out that window. So I teach here at UC Berkeley. I'm in the Department of Operations and Information Technology Management. I teach courses in business analytics. We teach our business students, both our MBA students as well as our undergraduate students, how to leverage data and how to use data in decision making. But I also teach product design. And so my own research is in the area of text and sequence mining. I apply it to identifying and selecting opportunities for new product and service development. Most of my research is in consumer products as well as in healthcare services. But that's basically what I'm doing here. I also serve as the Director of Data Science for our Fisher Center for Business Analytics. So I'll shill for the center for a second and say that we're always, on behalf of the entire Haas School and the university, we're looking for opportunities to partner with firms like those of you, those that you represent. And if you're interested in collaborating with the university, or in particular with any of the faculty at the Haas School, whether it's in marketing, operations, finance, accounting, but in any application of AI in business, as the panel is addressing, please reach out. We would love to partner with any of you and all of you. So, thanks.
Soma?
So, hi, my name is Soma Velayutham. I was born in India, brought up in Malaysia, Singaporean, and I live here. So you can ask me about AI, but if you ask me where is home, I usually struggle to answer. So I work for NVIDIA. NVIDIA has emerged in the last years as the AI computing platform. And it's been a phenomenal journey working with NVIDIA. And I actually have a telecoms background. I've done a lot of work in Bell Labs and then later in Nokia and now with NVIDIA. And some of the work that currently I'm involved in is very exciting because we believe that we are in the confluence or just about to break off where IoT, connectivity in 5G, and the ultra low latency cloud, the confluence of cloud computing, edge computing, edge cloud computing, AI, and 5G and IoT, the connectivity is all coming together. So some of the things that you've seen in the last 10 years, I think it's just going to get even more interesting in the next 10 years, especially with connected cars and so on. So I focus on AI and accelerated computing with the focus of this connected computing. and 5G. So I'm happy to be part of the panel. And
thank you. Thank you so much. Let me start with the first question. Has AI redeemed the promise or the hype? Do early adopters get a competitive advantage? Charlie, why don't you start off? Because you actually use AI in your business directly and you sell. Just tell us how it's being used in business. Has it redeemed the promise it has made or the hype?
Okay, so by the way, as you know about Salesforce, our building's gone off the pic. Can you put the building back up? No, I'm just kidding. No, there it goes. Okay, we hype everything. So, don't quote me on that, please. Anybody from the president? No. So the promise of AI, we have an unfair advantage because we are in the cloud, as mentioned, and we have a lot of data. So when you have a lot of data and you're in the cloud, and the customer opts in, then you can apply AI to their data, their massive amounts of data. And what we've done to fulfill the promise of AI is focus on the areas that are our core competency. So for example, we're known for Salesforce Automation. So what's the first thing you get exposed to in Salesforce Automation? A lead, right? A lead comes in, and what do you do when you see a lead form? It's got like 50 different fields on it, right? And you go through each field and say, okay, they have this characteristic and this characteristic and this characteristic, right? What a mundane task for a human to have to perform. Why would you have a human perform that task day in, day out? And there are still companies out there, believe it or not, doing manual lead scoring. Well, Salesforce customers can apply, we call it Einstein, AI, to that lead, which is a really easy use of AI, because AI can learn as you go, right? It knows that if you fill out these 20 fields this specific way, that lead is going to go all the way through. We have these things called, well, you call them whatever you want. They're customizable, but they're steps in the sales cycle, right? So there's a whole life cycle of a customer. So if you go from step 1 to step 2 to step 3, and there's a success after step 3, and that resulted from these 4 fields being filled out in this lead form, and it's scored appropriately, guess what? That's an easy application for AI. So we start off very simple with that, and we also cheated in that we acquired about 20 different companies, and we have a view of AI that it's not just about correlative analysis. So we've hired 2 or 3 companies that do correlative analysis. We have companies and we hired Dr. Richard Socher from Stanford University. Sorry about that. Okay. Boo, boo, everybody boo. Okay, no. No, he's a really bright guy, but he's really good at NLP, right? His whole team of that's another aspect of AI that is important to us, because you want to be able to type in English or speak English or whatever language happens to be your language, and you need to see a result, and you need to fill out, for example, that lead form by just speaking, or you need to be able to do things like trouble ticket, assignment to knowledge articles. So that's another thing AI is pretty good at, right? Case scoring. So you have a trouble ticket, which is called case management. Why not retrieve the appropriate knowledge article and bring that back to the customer? So we have very easy, basic use cases for AI, and we have more complex use cases, but I'm talking too much, so I'm going to hand the microphone off to somebody else.
So it's working. Soma?
Yeah.
Because, you folks use a lot of AI in your chips.
Well,
Are the chips use a lot of AI? I mean, the chips used for AI.
So what would you again the question?
No, the question is, has AI redeemed the promise beyond the hype? Are early adopters getting a competitive advantage?
Yeah, I think it's absolutely yes, right? So let's break AI down in terms of how I view AI. I think AI has the machine learning aspect of it, where it's doing a lot of, as Charles was saying, a lot of contextual information on text and data, big data. And then there's another chapter in AI, which is deep learning. And deep learning is where computer vision and NLP is very advanced. So both of these confluence it's really delivering a lot of promise. Definitely in the autonomous driving, in smart cities, computer vision is becoming very dominant. Now, the way I look at AI is automation of automation. Automation is always happening. We've automated for the last 20 years. IT was all about automation. The thing was, IT was driven by logic. Somebody had to sit down and say, if you did that, let's do this. So it was a logic-driven automation where you needed a human to close the loop or human to write the logic. AI is, the automation is itself automating. So basically, the AI just learns the information, it studies data, and then decide, you know what, Soma went for lunch on Tuesday. Every Tuesday he goes for lunch to an Indian restaurant. You know, should I offer him an Indian food on Tuesday morning? So it's as simple as that, to be able to study the data and to be able to draw an inference on the data without you having to write the logic. So AI is nothing but an automation of automation, and that can only thrive if you have a lot of data and a computing power that can manage a lot of data. And smart algorithm engineers who can actually write algorithms to teach the computer to learn.
And the chip that can process.
Yeah, that's computing.
Okay.
Absolutely.
Stratos, what is your view? I mean, you worked with IBM, Watson, and all that.
And
Geo 2, of course,
yeah,
Geo
thank
2.
you. So you want to know about the hype, and at every stage of AI, there is hype preceding that stage, right? So today, the hype is about general AI, which is broadly autonomous, distributed, and explainable AI with a fair amount of autonomy. That is where the hype is. But there are two other stages. There's the narrow AI stage, where you have purpose-built models. And those work at a very high accuracy. And those have been at work for several years now, humming away. It's just that we're getting used to them, and our expectation keeps changes. So these are assumed today. And then there's this middle stage, which is called broad AI, which is distributed, explainable, unbiased, and it can do more than one things. So you can develop a model that can look at a picture and be very descriptive as to what it sees. So different levels and different hypes. I will drill into each one of these at a later stage, because I know your line of questioning. I hope I answer your question.
Yeah, but early adopters got an unfair advantage compared to others. I mean, give us your geo experience, if you can.
So I'll talk about Geo, because I know there's a lot of interest in the audience, but I'll also talk about a study, which I'm not sure if it's publicly available, but I was exposed to it when I was at IBM. And the gist of it is that not everybody is on board with AI. Certain verticals are ahead of others. Healthcare is the number one. They're the ones that are receiving the most benefits out of it. And I think part of this is also the humanitarian aspects of what healthcare can do. The main area for healthcare is diagnostics. Right? Look at an X-ray, tell me what you see. And that is applicable when the expert is not available. So to put it in the context of smart villages, medical doctors might not be available in those smart villages. And having a system that can accurately predict read and predict what's the likely issue with a patient is extremely powerful. But here's where the hype is. The hype is we expect AI to be 100% accurate every single time. And here's where the reality is. The reality is that medical doctors, and as a result of misdiagnosis, there are thousands of people that die every day.
Oh.
So if AI gets one or two wrong, and with Watson Hill there was something in the news, then everybody's against it, right? The other thing to understand is that there is bias, and because AI is primarily today built on top of data, that data has inherent bias. How many times did you go to a doctor, you didn't agree with their opinion, and you want a second opinion, right? So that means there are two conflicting points of view on the same patient. If that becomes a data set and AI learns from it, then it's likely going to give an opposing view, and the outcome might be completely different, right? Geo. I did forget. Here's the challenge with Geo. The market was saturated. If you look at the smartphone business in India, it's about 300 to 400,000 consumers. If you look at the feature phone business, another 400,000. And then if you look at the remaining 400,000, they don't use a phone at all or never been exposed to the internet.
Million. 400,
oh, I'm so sorry.
400 million.
Yes, I was thinking in lakhs. You're absolutely right. Thanks for the correction. So how do you enter a market where Vodafone and Airtel are number one, number two, and peel off customers, right? You have to be 10x better than them. And building a company that self-optimizes by using AI was extremely important to Mukesh Ambani and the crew that I worked with. So that's what we set up to do. So the fact that the network is optimizing using AI by understanding whether you're overshooting a tower or you connected due to elevation, what else can be done, and really understanding the locality of the issues is extremely important. On the customer service side of the business, we developed one of the first really advanced virtual agents that live on your phone. Right? And the reason it's really advanced is that today it's a commodity, but it did some things that nobody else can do today. And I know because I worked at Apple prior to that. It can do edge-based diagnostics. So the phone itself is the probe to anything that you do. And the decisions that it's making are local to the phone itself. And that's extremely important when you're trying to understand connectivity issues or bandwidth issues, right? You cannot call the call center, regardless how automated it is through Salesforce, and expect the agent to really know what were the circumstances when the problem actually happened. And I think that was a major breakthrough. What that did, it just created some really happy customers. And as for those of you that know the story of Geo, the name of the game changed from turning unpaid customers to paid customers because we had a 1-year trial for everybody. And because the network was so much better than anybody else, we had that conversion to be extremely successful. All right.
Okay, before I go to Ganesh, how do you rate the Geo network since you worked on that? It was AI first compared to all global networks.
All right, so good question. Number one, it's a 4G upgradable network to 5G and beyond. There is no fallback network, right?
Oh.
So typically 4G doesn't work really well in buildings. So the interesting challenge is how do you fall back to a secondary network and what rate you're going to pay when you don't have availability for 4G. The second thing is it's pan-Indian. So from the fiber optics to submarine cables to everything that goes with it, the project is massive. And in terms of speed, it's one of the best speeds you can experience. I think my Geo speed in Mumbai, in Navi Mumbai, was significantly higher, about 2-3 times of this AT&T speed that I get at my home, right? So India is a very lucky place. And I'm flying to India on Sunday, and I'll check it again, and I can report back.
Okay, that's good.
You can drop the mic again.
Ganesh,
Yes.
you have been another AI-first company. Just tell us, is the AI, reality as good as we think it is for you?
It is absolutely a reality. Here's the reason why. I mean, if I look back, or if you all look back in the last 30 years or so, all the industries have shifted from, digital to connected, now entering into the data age, right? Data is nothing but data science. So AI is nothing but statistics. What is the probability of certain things could happen, may happen, will definitely happen? For that, you need all the data. So the IoT industry is shifting towards AOT industry, which is autonomous of things, right? So the data explosion is happening all around. It's happening in autonomous driving industry. We have seen Teslas, now NIO. So it is not a myth, it is real, right? So I was looking at the Gartner report, I think it was 2018 report. They predict by 2020, more than 40% of all of the application projects should have and will have AI engineers embedded within them. Otherwise, the organization will fail. You have to start plan for it. So those organizations who have planned in advance recruiting those machine learning and deep learning experts, I think they will definitely have an edge over the others. Tesla is a classic example. How they disrupted using AI. Now the car does most everything for you, right? Jokingly this morning, my communications lead, Joanne and I, we were taking an Uber from San Jose to here, 6 a.m. in the morning. We were just chatting, and then she said, I am short, but I haven't seen even one car which can automatically adjust my seat.
Oh,
Not even one car.
that's your expectation.
That's expectation. Consumer behavior changes.
Wow.
Because everything is user-driven experience now, right? There is no reason why we cannot have the seats automatically adjusted based on your persona. Because facial recognition is there. Camera is embedded within anything and everything, right? So easily, there is no way that our car seats can adjust by itself.
You might have to focus on not your face somewhere else to do your.
Starly cool. That's Einstein way of solving it. But this is so it is real use case, right? So within Neo, what we have done is, as I mentioned earlier in my opening remarks, that we're not building a car, we are building a digital companion. For that, we talked to various people. We did a lot of user insight study. What do you like in today's cars? What you don't like in today's cars? So the common things that we have seen or we heard from these users, these are doctors, engineers, soccer moms, baseball dads, you name it, spectrum of people we interviewed. So what they don't like is today it's mostly everything I still need to interact. Though it is digital, I still need to use my fingers. HVAC system, right? You may like, as soon as you open the door, you may like, full-blown air temperature at whatever degree centigrade, and then the blow of the air speed certain way. The moment your spouse comes in, she hates the air vent. It changes, right?
Yeah.
There's no reason why we can automatically, contextually, the vehicle cannot deliver that user experience for both the driver as well as the passengers. So we used first we heard was about, I don't want to touch it because that's a distraction, and a lot of the accidents are happening because of distraction. We thought, how can we make conversational AI embedded within vehicles, right? You can talk to people, you can talk to the car. So with the Neo, we came up with the first instantiation of AI, we call it Nomi. Know me, but spelled as N-O-M-I.
Nomi.
Which is the first, first in the automotive industry, in the production cars, that can actually do a conversational AI. You can check it out. Any of you are welcome to our new office, and you can feel yourself. So AI is nothing, Nomi is nothing but a conversational AI robot, which is very funny, very smart, and is expressive. It has emoji-like look. Depending on when you get into the car, if you suggest, it'll say, "Hi, Mohandas, good morning to you."
Oh.
It knows your birthday because you said it once in the car. I said, "Happy birthday to you, Mohan."
Oh.
So it's very expressive AI agent because conversationally
Will
you can.
it know what I do in the car?
We'll talk it after the panel. But in general, I'm saying that is where the industry is moving. That's where we see it. So AI is not a myth. It is real. And organizations who invest in early in machine learning, deep learning engineers will be successful. Certainly, NVIDIA is leading that also. So I just want to conclude one more point before I go. So I happen to be with Jensen, your CEO, and with a dozen school superintendents. And the topic was, will AI replace teaching profession? It's a cool subject, philosophical subject. And these are superintendents of well-known high schools in the United States, in the Bay Area. So the point they were trying to illustrate, and we all learned, for example, what's the capital of India? The teacher told me, and 10 times reinforcement learning. I said, yeah, it's New Delhi. Today, the students don't have to have it. Cortana, Siri, Alexa, what's the capital of India? Will give much faster than the teacher taught you before, right? So the teachers may become validators, meaning the conversational AI is taking over that profession. So if we don't apply this AI principle correctly, it can be dangerous, but it has merits as well as demerits. But it's the application by application.
It's real.
It is real.
And working.
It is working.
And gives you a competitive edge.
It is absolutely a competitive edge. Any industry.
Any industry.
Any industry.
Now, Doc, you are the academic amongst us. What is your verdict? What is your verdict to whatever they said?
I was going to say what's rather depressing to hear I'm going to be out of a job soon. The other thing that I learned from being on this panel is clearly Berkeley doesn't pay me enough because I don't know about the expectations for the rest of you, but I don't think I've ever even been in a car that would adjust the seat for a seat to me. I feel like I'm doing pretty well when I can press the button and the windows roll down instead of me having to roll it myself. If I was going to leverage off of Stratos' answer, there clearly are different generations of AI. And so I guess the perspective that we take here teaching in at least the Haas School of Business is that AI, if you think about it more generally speaking, the value of data is very much a cost of doing business, right? No longer do you think of it as a differentiator. If you're not playing that game, you're not able to even compete, right? And so you'll find that in our curriculum, data and leveraging data is a part of every one of our disciplines, right? Whether it's management organizations, whether it's in finance and accounting and operations and marketing, right? It's all of those things. And to the observation about the importance of this or its differentiability, I don't know if anyone here saw an article in this morning's Wall Street Journal. It's about sports, and so I'll use the sports analogy, even though not everyone here may be particularly into it. This was an interview that they had with the general manager of the Houston Astros and the general manager of the Houston Rockets. So that's Major League Baseball and the National Basketball Association. So if you're not into sports more generally, let me at least observe that these are two teams that are prominent in the professional sporting world for their leveraging of data. Right, so one of them recently won a world because there's one team in Canada, but world championship. The other team, while they haven't actually won a championship, they've set records for wins, for three-pointers, for innovating in the basketball space. Both teams are arguably unique in the way that they've leveraged data and technologies in their management of their organizations. But in this interview, what was notable about it was they said, look, years ago, what was great, I'm grossly paraphrasing here, but what they said, years ago, what was great is we were the only ones using data, right? We were the only ones applying intelligence. And even though we had bad data, having bad data is better than no data, and everyone else had no data. The observation, though, was today, everybody has data. Right? It has ceased to become a differentiator. It has ceased to become a competitive advantage. Because if you're not playing that game, you're not even on the playing field. And so I think that's where I'd leave it.
Okay, now let's go to the next question. I think it's important. I'll start with Ganesh. Ganesh, what is the bleeding edge in AI? What do you think we're going to see in the next 2 or 3 years? And then talk to us about what China is doing. $150 billion spending by 2022, wants to dominate the world. They got human capital, financial capital, political capital, every capital. And what are they going to do? And what are the rest of us going to do compared to that? And you are there.
I'm there.
Not there. Okay.
I'm there. It's a great question. Where do we start? China first or the bleeding edge?
No, start the bleeding edge, then come to China. Bleeding edge is general for everybody.
Yeah, I mean, bleeding edge, obviously it's happening across all the industries. And, I'm most familiar with the auto industry most recently, the last 8 years. But other than the auto industry, if you look at the mining industry, for example, now the mines are being operated and maintained by robots. Pretty much in most of the mines, right? How is that possible, right? So sewage industry, which is even worse, right? Imagine, wouldn't it be nice if probably the same time next year, there could be a leakage on the sewing pipe, which is underneath the water, underneath the soil. Today, we come to know there is a leak when the leak happens. But when these robots go through, for example, through these pipes, it is taking probably, if not thousands, tens of images, right? Today the engineers actually look at those images and then make some prediction manually. But now that technology is there, using machine learning and deep learning, you can scan even millions and millions of photographic images in split seconds. So the point is, with machine learning, with the assistance of this data, and then companies like NVIDIA's, the advanced chipsets, information can be processed much, much faster than we would have ever imagined before, right? Before that, in the sewage example, the leak could happen. You know what? we can actually even predict and send the maintenance engineers to go and then fix it before the problem occurs. This would not have been possible. This really happened in Washington, D.C. I was reading an article. There's a DC water, which is water, sewage processing and water supply in Washington, D.C. They did a project together with one of the Indian SIs. I won't name them, but together, I saw the case study and I said, yeah, it is real. Actually, they were able to predict this part. Take another example. Let's the infrastructure, power industry. If the power goes down right now, what's the impact, right? There's no reason why that tree cannot fall onto that transformer. But if it does, then there is an impact. But now the data is there based on the rainfall data and then the vegetation information, all of that. So predictively or in advance, we can predict potentially tomorrow morning that tree might, there's a 99% accuracy that tree might fall into that transformer. Let's go and then send the maintenance crew and then fix it. So that's another use case, bleeding edge, where it depends on the application and then using the right use cases, it is coming. And the autonomous case, which is a driving, again, I'm most familiar with, there are 5 degrees of autonomy, right? It's a level 1 through level 5. Simple terms I explain to people. Level 1, every car has it, which is cruise control. You take your feet off, set the speed, car drives by itself. That's level 1. Level 2 is your feet off plus hand off, which is sort of Tesla, right? You are still driving, you are in control, you are still keeping a bird's eye view of the road. Level 3 is your feet off, hand off plus eye off the road. And what we are now, using machine learning and AI, we are into the level 4 world. And level 4 is basically you are not driving. Imagine having this meeting we are having inside a level 4 autonomous cars while we are being driven to San Francisco.
So mind is off.
Mind is off. Feet, hand, eye, and then mind is off. The car is making the complex decisions using the data it sees around the car, around you, as well as everything else. It can make, and it is making, capable of making the predictive analytics, what could happen before that thing happens, right? So it is real. These are some of the bleeding edge use cases that I see as autonomous cars are already, it's applying those. And this DC water example I gave, that's a proof point.
Will we see the Star Wars robots?
I think we will.
Oh, really?
I think so.
Okay.
So that's my take on some of the bleeding edge. And
China.
I talked about
China.
Oh, China. As a matter of fact, just for fun. So 2 weeks ago, I was coming back from Shanghai. So there was no Wi-Fi in the plane. So I said, okay, let me look at my passport. I just looked at, curiously, I counted the number of stamps I had. I couldn't believe it. So 26 times in the last 3.5 years, I traveled to China, more than being an Indian traveled to India. So the point I'm trying to make here is, every time I went to China, I came back with much more respect for the country and then the citizen and the infrastructure. Blows me off, right? There's no reason why India cannot have even equal or even more.
China, US. China,
US, right.
We are part of the US for AI.
So China is exploding from an infrastructure standpoint, technological standpoint, smartness standpoint, and AI standpoint. When I say AI standpoint, that's a core subject. The auto industry alone, there's about 400 or so startup companies trying to do the same thing in China alone. And how many of them will make it? We will find out. But not everybody's trying to build a car, but they are developing technology, so the intelligence, AI intelligence for the car, when the car becomes as part. China is real. I think it's really, really advanced with respect to the autonomous.
Soma? Bleeding edge and China, because you're in the chip world.
Yeah, we like to, you used the word chip a few times, but I would like to say we are a computing platform company, an AI computing platform company. As Steve Jobs said, to make good software, you need good hardware, and likewise, right? So bleeding edge, I see that, from an AI perspective, deep learning, computer vision and NLP has advanced a lot, really. Conversational AI is a reality today. But we already do this in our research, and we see this also happening in the near term, is what we call a sensor fusion, where the video is one sensor and audio is another sensor, microphone, and both of these starting to come together. So we could have conversational AI, and what it means is, instead of showing this as you walk into Walmart, show this and say, can you charge for this? and a computer vision taking a photograph of this and recognizing it. You could actually just walk in and say, hey, Walmart, what is that? And because I'm pointing at it, the computer understands it. And then because I'm talking to it, it understands what I'm asking for. It actually looks at it and says, that's a Nestle bottle, 50 ml, and that's 99 cents. Would you want one? So we see this AI and sensor fusion happening, and AI becoming very conversational, and not in the sense of just voice, but voice and video coming together. So that's our leading edge that I see in the near term, actually.
China?
China, as Ganesh says, what can I say? I mean, they are way ahead. I mean, I don't even know where to start. I mean, they are way ahead of everyone, right?
Everyone?
I think so.
Including the Valley?
Yeah, I would
think
safely
so?
so. I would say so. Collectively, yeah.
Okay, Stratos?
Yeah.
All right. Well,
Bleeding edge first.
bleeding edge. I had the privilege to be exposed to a lot of classified projects, so it's very hard to talk about bleeding edge and kind of not reveal some of those. And one parenthesis here on the bot nerd, and to prove that, before Siri made it on an iPad, I had a custom version of Siri that asked on my behalf, proposed to my wife, my
Oh my
girlfriend
God.
back then.
Cool. Really?
And there's actually a video of that now on the internet. I couldn't disclose that while I was at Apple because that was a sackable offense. All right, so going back to bleeding edge, I have three, right? The first one is in the space of distributed learning. It's called federated learning for technical terms. And really the idea is data, with the exception maybe of China, data is highly regulated, including India, right? So how do you build models that are protecting the privacy of individuals and ensuring that those models are not shared within the company, across companies, and outside your country? So one of the things we're doing, basically, we use a CDN network that was recording some of the data in Singapore just because where the edge server was, and that was a big deal with the Indian government, right? So we had to shut it down very quickly. So the bleeding edge is how can you create centralized or decentralized asynchronous learning and then create supermodels as a byproduct of that. And the way, I think this is a published paper, and also there are some assets that are actually working really well. The idea is to take pre-trained gradients and merge them together either centrally or locally to create supermodels, right? So imagine that this half of the room understands digits, and this half of the room understands letters, and a supermodel understands both sides, and you both get the benefit of it, right? So there's a lot of work that's happening in that area, and it's pretty fascinating. The second one is around robustness. So one of the things that might be surprising to many is that AI models are vulnerable to adversarial attacks. And those have some severe consequences. And these are not just for computer vision, it's also for audio as well as text. So what you can do, how does it work? Access to data is today a myth. Everybody has access to data because there's a lot of data out in the wild. Those are poisoned data sets, or the majority of those, that allows an adversary to manipulate the outcome of AI at runtime. Right. So if you take computer vision and laser vision for autonomous vehicles, AI can be fooled by contaminating the scene and removing all the pedestrians from the street. Right. And the way you contaminate the scene is very trivial. Basically, you go at a T-junction and you add some stickers on the walls or the signs, and all of a sudden now you have control of what the vehicle can see, right? And there are many of those. So there is a lot of work that was done, and we continue working on that to first of all identify poison inside data sets, as well as identify the vulnerability of AI models. And there's a big IBM Watson, I think, release that did AI for AI, and the idea is to create derivative models that are robust and don't suffer from those adversarial attacks. The third one that I had the privilege to work on for a little bit, and it was always a fantasy of mine, is to change how AI works. Right. So today AI is more of a waterfall approach. Take the data, do some feature engineering, train a model, test it, either using the same data to understand how the system can self-predict, or an unseen set to see, to do your cross-validation. And then if that is 80, 90% or so, you're happy, you roll it out, and then you rinse and repeat. Right. So the result of that is that the model that is out there knows the state of the world as it was when the data was collected. Right. But that's not how we work as human beings. And you want to get to a point where the models learn as a byproduct of inferencing. And there are two things I've been exposed to that get me really excited. One is the algorithms themselves that had the capability, in particular in neural networks, where your softmax layer is dynamically enhanced by new things that you never anticipated prior to that. And then the synapses, the connectivity between nodes, are really formulated as the model is used, as opposed to trained. The second part that is very interesting is on the hardware side. I think I'm getting a cue to go a little bit faster. On the hardware side, that maybe is applicable to NVIDIA, there's some very interesting end-by-end matrices of hardware components that do exactly that by just using the chipsets to act as nodes in a neural network. China. Very quickly on China, part of the concern is IP infringement. I came from India. That is a myth. Let anybody infringe any IP. It's not important. That's how we make a dent in the universe and move forward. So welcome competition out there. And if competition is built on top of something that you've done, then that competition may produce something that you can build upon later, especially in drug discovery. The fact that you failed the clinical trial is extremely valuable data for somebody else to build upon and discover a drug or repurpose your drug to solve a mastic or a real problem in humanity. So to me, and my answer is a little bit controversial, so IP infringement is not a big deal. Maybe because I'm an innovator, so I believe I can continue innovating for the rest of my life. But the interesting thing that China has done, it actually unleashed the capability of data. And to me, this is massive because it allows you to build better and more robust models than you would if you didn't have your accessibility to that data. So if I was to loop back to the first breakthrough, which is federated learning, that is the innovation that we're contributing here in the Valley to actually make that as a totally unimportant factor in moving AI forward. With that, I'm going to pass it over to
Charlie, quick one.
Quick one. Okay, I'll go quickly. I don't know much about China. I know we have a partnership with Alibaba, so I won't talk about China. That'll save China. But on bleeding edge, I mean, I do bleeding edge stuff with my customers every day, and I'm like Stratos, I can't talk about it because that would be divulging information that's private to them. But I can tell you, like the use case you mentioned earlier about being able to point at something and get help for it. We call that thing help. We published and talking about leveraging IP. We process patents at Salesforce all the time, like that one called thing help. But we don't go after any company for any patent infringement or intellectual property. So we open up everything because we want all of our customers to use everything we do. So if you wanted to leverage technology where you walk into Walmart and you point at something and either it knows your NFC from your phone, it has a low power Bluetooth beacon, and it says, oh, I'm standing in front of the water aisle, and if I speak into my phone, Siri should know my context. You were talking about context earlier, right? And I think that's the bleeding edge technology that's coming in the future. Is all about what everybody said here. I see a recurring theme. It's all about putting your sitting down in the car, that knows who you are, it knows where you are, it knows what your seat is supposed to be like, and it pushes all that information somewhere, either processed locally through the NVIDIA platform or sent up to the cloud, but it should know your context. And the bleeding edge around that is a little bit about something you said. It needs to know about your privacy, right? And that's where I think the huge challenge is in the future. It's about privacy and confidentiality, security, and ethics. And I don't know if we're still going to talk about that, but ethics is extremely important because you talked about training models. Just like you could train models to be smarter and smarter, you can train them to be biased. And you talked a little bit about bias. I thought that was great. But if you train your model to be biased in really bad ways, in negative ways, and you can do that with some Salesforce technology. So you need to be completely aware, not from just an overarching product standpoint, but how your company is applying AI technology in your own environment so that you are ethically using that product. And I'll be quiet now at this point. That's my Reader's Digest version of Bleeding Edge.
Professor, for you, you're the last word.
So I'll try and make this really brief. One thing that I think that related to something that Stratos has mentioned, but I think is going to be truly fascinating on the very near-term technologies is, broadly speaking, what's called transfer learning, and more particularly zero-shot and one-shot learning. The reason why I think that's particularly fascinating and interesting is because at a high level, it means how do you learn? We just spent, the last hour of your time talking about why data is important, having lots of data is good. These technologies are technologies that allow you to learn having less and less data. And the reason why that's important, and it segues off of to the second question that was asked related to China, is one of the big differences between the West and China's research in artificial intelligence has to do with, without trying to make it seem insidious, is a different cultural norm around individuality versus social good, right? And the good of the collective whole and social order as opposed to individual liberties and privacy. And so that's not to say one is better or worse, but because of that difference in sort of cultural norms and expectations, China has been able to leverage data from its population in ways that are simply not permitted in the West, right? And so there are some great opportunities and technologies for things like federated learning because of it, but a lot of the advantages I would argue that we see emerging out of China largely has to do with their ability to exploit data in ways that people in the West are not permitted to. Or maybe they're not supposed to be, and maybe Apple does a better job than Google and Facebook does, but we won't go there, right? So the idea that one can begin to develop algorithms that learn from less and less data begins to mitigate the imbalance due to those distinctions.
Okay, folks, so we have to end this session we'll have two questions. We were supposed to talk about the issue of ethics in the age of AI, and we're supposed to talk about ethics when machines get intelligence, but I guess Dr. Darwin is not giving us the time. It's very interesting, so we'll park it.